Dear learners, myself Dr. P. Shaktivel. So we are going to discuss about the field effect transistor and junction field effect transistor. So in this video, we have to see what is the FET, types of FET, JFET and working of JFET. What is JFET? So we have discussed in the circuit applications of any transistor. In this type of transistor, both the holes and electrons play part in the conduction process. For this reason, it's sometimes called the bipolar transistor. So the ordinary bipolar transistor has two principal disadvantages. First, it has low input impedance because of forward biased emitter junction. Secondly, it has considerable noise level. So although low input impedance problem may be improved by careful design and use of more than one transistor, yet it is difficult to achieve input impedance more than few megaohms. So the field effect transistor has, by virtue of its construction and biasing, the large input impedance which may be more than 100 megaohms. So the FET is generally much less noisy than ordinary bipolar transistor. So the rapidly expanding the FET market has led many semiconductor marketing managers to believe that is the device will soon become the most important electronic device. Primarily because of its integrated circuit applications, we have focused our attention on the construction and working of and circuit applications of field effect transistor. Next, types of field effect transistor. A bipolar junction transistor is a current controlled device. The output characteristics of the device controlled by a base current and not by a base voltage. However, in a field effect transistor, the output characteristics are controlled by input voltage. Input voltage means the electric field and not by input current. This is probably the biggest difference between the BJT, that is called the bipolar transistor, and field effect transistor. There are two basic types of field effect transistor. The first one, junction field effect transistor. Next one, the metal oxide semiconductor field effect transistor. This is called MOSFET. So to begin with, we shall study about JFET and then improved form of JFET, namely MOSFET. First, JFET. The junction field effect transistor is a three-terminal semiconductor device in which current conduction is by one type of carrier. Example, either electrons or holes. The JFET, the junction field effect transistor, was developed about the same time as the transistor, but it came into general use only in the late of 1960s. So in a JFET, the current conduction is either by electrons or holes and is controlled by means of an electric field between the gate electrode and the conducting channel of the device. The JFET has high input impedance and low noise level. The construction of JFET consists a P-type or N-type silicon bar containing two PN junctions at the sides of P or N. So the bar forms the conducting channel for the charge carriers. If the bar of N-type is called the N-channel FET. The N-channel FET. And if the bar is P-type, it is called P-channel JFET. So two PN junctions forming diodes are connected internally and common terminal called the gate is taken out. The other terminals are source and drain taken out from the bar as shown in the figure. So the JFET has essentially three terminals: gate, source and drain. The next J4 polarities. The first figure shows N-channel JFET polarities, whereas the figure 2 shows the P-channel JFET polarities. Note that in each case, the voltage between the gate and source is such that gate is reverse biased. So this is the normal way of JFET connection. The drain and source terminals are interchangeable. Either end can be used as a source and other end as a drain. Actually, the main points we noted, the input circuit of JFET is reverse biased. This means that the device has high input impedance. The drain is so biased with respect to the source. The drain current means ID, flows from the source to drain. The next point, in all JFET junction filter transistors, source current is equal to the drain current. IS equal ID. Next, principle and working of JFET. The figure shows the circuit of N-channel JFET with normal polarities. Note that the gate is reverse biased. The principle, the two PN junctions at the sides form two depletion layers. The current conduction by charge carrier means free electrons in the case. The charge carrier is through the channel between the two depletion layers and out of the drain. The width and hence resistance of this channel can be controlled by changing the input voltage. So the greater reverse voltage is wider will be depletion layers and narrower will be the conducting channel. The narrower channel means greater resistance and hence the source to drain current decreases. Reverse will happen should decrease. Thus, the JFET junction fit of a transistor operates on the principle that width and hence the resistance of the conducting channel can be varied by changing the reverse voltage, means in a high GS. So in other words, the magnitude of the drain current can be changed by altering the reverse voltage. So the working of JFET under two conditions. When the voltage IDS, the drain source current, is applied between drain and source terminals, and voltage on the gate is 0. So the two PN junction at the sides of the bar established depletion layers, the electrons will flow from the source to drain through the channel between the depletion layers. The size of these layers determines the width of the channel and hence the current conducting through the bar. The second point, whereas the reverse voltage is applied between the gate and source, the width of the depletion layer is increased, that reduces with the conducting channel, thereby increasing the resistance of N-type bar. Consequently, the current from the source to drain is decreased. On the other hand, if the reverse voltage on the gate is decreased, the width of the depletion layer is also decreasing. So this is the increasing of width conducting channel and hence the source to drain current. So it is a clear form of the above discussion that the current from source to drain can be controlled by the application of potential of the gate. Potential of the gate means the electric field on the gate. So this is the reason the device is called field effect transistor. It may be noted that a P-channel FET, P-channel JFET operates in the same manner as an N-channel JFET. Expect the channel current carriers will be the holes instead of electrons, and the polarities of gate source voltage and drain source voltage are reversed. Next, schematic symbol of JFET. The figure shows the symbol of JFET. The vertical line in the symbol of may be thought as channel and source and drain connected to this line. If the channel is N-type means the arrow on the gate points towards the channel. However, the P-type channel means the arrow on the gate points from the channel to gate. The JFET acts as like a voltage control device and control the output current. This is different from the ordinary transistor. Ordinary transistor means bipolar transistor, where input current controls the output current. Thus, JFET is semiconducting device acting like a vacuum tube. The need for JFET, because the modern electronic equipment become increasingly transistorized, it became apparent that there were many functions in the bipolar transistor were unable to replace the vacuum tubes. Owing to their extremely high input impedance, the JFET devices are more like vacuum tubes than are the bipolar transistor, and hence are able to take over many vacuum tube functions. Thus, because of JFET, the electronic equipment is closer today being completely solid state. Next, summary. So, summary of this video, it concludes the field effect transistor. The field effect transistor is a three-terminal device, and JFET symbol and JFET polarities. Polarity means N channel FET, P channel FET, and then working of JFET. Thank you.